Hi everyone, welcome to my channel. Subscribe to my channel for more videos and click the bell icon for further notifications. Another interesting question from the year 2023 has been picked. It's based on applied mathematics domain. Let's give a try. It says between 3 p.m. and 5 p.m. the average number of phone calls per minute coming into the helpline desk of a bank is 5. The probability that during one particular minute there will be one phone call is. The options are 0.5 e to the power of minus 5, 5 e to the power of minus 5, e to the power of minus 5, 25 e to the power of minus 5. This question falls under Poisson distribution. Why I am saying so? Let's look into the reason. One more thing also I want to tell you here. Here the options are e to the power of something. So that also gives you a hint that it comes under Poisson, but the actual reason we should look into. It's based on requirements. What requirements it is satisfying we'll look into. A discrete random variable may be modeled by a Poisson distribution provided events occur at random and independently of each other in a given interval of time or space. So here they are saying a discrete random variable. What is said to be a discrete random variable? It is a type of random variable that can take a finite or countable number of distinct values. That means we can count number of cars met with an accident, or else number of persons went to the mall. All these things we are able to count and they are finite. So that is said to be discrete random variable. Now, here what they are telling us, events occur at random and independent of each other. For example, into our question, we have got phone calls. It's a random call and they are independent of each other. One call from one place will be getting and another call from another place will be getting. And they have fixed the time also like 3 to 5 p.m. And in the question itself, they have mentioned to us the average number that is said to be 5, right? And it's uniform finite. Finite means we are able to fix it. How many values are there? Are we able to count like that? That is said to be finite. Uniform means it's regular. They are telling you like a fixed one, the average number of events. So if it's so, our x represents the number of occurrences in a given interval, then probability of x equals r is equal to e to the power of minus lambda, lambda power r over r factorial for r is equal to 0, 1, 2, 3, 4 like that. Yes. So this is the formula. E is there and lambda is our average rate and r is the value, whichever thing they are fixing in the question. Here in the question they have mentioned per minute. They are fixing that as 1. So that only we have to substitute. So we can consider another example for Poisson distribution. Number of cars met with an accident. If I mention like per day, that falls under Poisson. If I mention like within 10 minutes all over the country, that also falls under Poisson distribution. So whenever a time interval, a fixed space, anything they have provided in the question, that falls under our Poisson distribution. So let's have a look into the question. So here they have given us the time interval. Now what we should do? We need to think about our formula. Yes, our formula is actually e power minus lambda, lambda power r over r factorial. Now r has been mentioned as particularly 1 minute. So that only we are going to substitute now. For one phone call they want only one. They are fixing that as 1. So probability of x equals 1 e power minus lambda, lambda power 1 over 1 factorial. And now lambda value also they have mentioned in the question, that is actually 5. Average number per minute is actually 5. So as they have mentioned one phone call, r becomes 1. As they have mentioned average number to be 5. So that is actually lambda value. So that only we are going to substitute e power minus 5 times 5 over 1 factorial is simply 1. That means the answer is 5e to the power of minus 5. The answer is so simple. Second option is the right answer. If we follow the formula, easily we are able to get. I hope you are able to follow this concept. Thanks for watching.